Okay. And that leads us into power system analysis. 4A is arguably the most, at least I can in absolute terms say that as far as the reference handbook content is concerned, 4A is the most advanced section, correct? Because 4B is missing in the handbook. All right. So 4A definitely is the most advanced. Why? Because we have TLMs, transmission line models, transformer connections. Remember the switch diagrams we were looking at? Power flow, which can, if you take a step outside of the equations that they've given in the handbook and start discussing different scenarios, right, based on the angle delta and the voltage magnitudes, things do become quite interesting very quickly. Power system stability, if you want to take a deep dive into it and, go through the equilibrium criterion system step by step, it does get very interesting. And obviously, how can you ignore fault current analysis, right? Which brings the per unit systems, which brings the symmetrical components, which brings the three-phase configuration, delta Y, everything together, right? Sequence components and everything, and transformer connections as well. Power quality. I mean, you can look at the voltage unbalance equation and the TAD percentage equation that they've given in the handbook and, try and sleep comfortably at night, right? But that power quality in itself is a specialization, right? And how can you talk about power quality without giving due respect to harmonics? And that's exactly what we did. Right? We dialed into the harmonics, correct? We looked at the positive, negative, zero sequence harmonics, helped us understand what triplet harmonics are, how we can mitigate harmonics, right? What are the sources of harmonics? What is active filtering? What is passive filtering? A lot of application-oriented discussion. Power factor correction. We had been hammering this point from day one, and the confusion still remains, for some students, I'm sure it will always remain, unless you take serious action and really dig in deep. Right? The angle theta, Wasim, lagging power factor, this theta PF is always positive, right? And leading power factor is always negative. That's good. That's all I need to know. Well, that is obviously better than just looking at the power triangle, but then you got to remember that this power factor angle is calculated on the basis of voltage phase angle and the current phase angle. Does this have to be always delta or Y? No, it can be either or, as long as you're correctly accounting for the 30-degree phase shift, right? And remember, we did a couple of practice problems where we did one problem like 2-3 different ways, right? So yeah, line to line voltage is phase voltage in delta, and line current is phase angle in delta in Y, right? But you cannot just mix and match these. You will always get the correct answer if you're sticking with this formula, right? And when we get to transmission lines, remember, we always set this reference voltage to 0, and then automatically there's an inverse relationship that's created, right? Polarity flip. So students are looking at the current angle and they're saying, I thought that the angle is supposed to be positive when we have a lagging power factor. That's true, but you got to spell it out completely. Power factor angle has to be positive when we have a lagging power factor, not the current phase angle, right? So these small things, guys, we went through in a lot of detail, and I can assure you, I hope that none of you make these mistakes, but I can assure you students will still continue to have doubts about it if they have never taken any time to really understand this concept, very basic concept, and start hammering this from FE electrical. Okay, so power factor correction, we spent a lot of time, and voltage regulation had started making an appearance in transformers, and voltage drop had started making appearance in motors and transformers. And the big thing over there was magnitude only, right? And voltage drop, when we're dealing with voltage drop, use the equations properly, use the phasors, right? And then if you're using, make sure that what type of voltage you're calculating. Are you calculating voltage drop line to line, or you're calculating voltage drop line to neutral? They're two different formulas, right? And the other thing was length of a circuit. You have to be very, very careful. Is it the total length? Is it circuit length? Is it a return path, right? It's three phase, the value of K, and so on and so forth, right? So this section is really loaded with a lot of topics that can have so many different variations, right? And that's why we spend so much time on section number 4. I think 3 weeks, if I'm not mistaken, in our live training, which is basically 6 sessions, 5 to 6 sessions at least, okay? And that includes protection as well. All right, so let's quickly go through this, guys. Voltage drop, how are you guys going to rate it? Easy to medium. Okay, voltage regulation, guys. Voltage regulation. Voltage regulation, again, easy to medium, agreed. Power factor correction, PF. How are you feeling about PF? Good, easy. Good. Power quality. How do we feel about power quality? Easy to medium. Okay. Fault analysis. I think we all agree fault analysis can be challenging, right? So this along with power electronics are probably the two most difficult topics. Transformer connections. How are we rating transformer connections, guys? Medium to hard. But it's pretty algorithmic, right? It's pretty mechanical. Once you know how to deal with the connections, I think you just have to wrap your head around it once, right? TLMs, transmission line models, short, medium, and hard. Not hard, but long transmission line. So let's call it medium. I personally think they're easy, to be honest, because it's very algorithmic. You need to stepwise manner. What is the length? Okay, this is this type of transmission line. And then I have to set my reference voltage phase angle to 0, right? I have to divide the voltages, if it's a 3-phase system, always by square root 3. Remember? So I broke it down into 4-5 steps there. So please make sure you go through that and those type of nuances. In the long transmission line, we have the hyperbolic that we have to deal with, and we dealt with it both in terms of real terms and the complex numbers. Okay. Power flow. Power flow, we have the good old equation for real power flow for 3-phase systems. Then we have the bus admittance matrix. And then, how do you guys rate that? Power flow, medium, and power system stability. Power system stability is also, I would say medium. Yeah, the equilibrium criterion derivation can be actually difficult. Okay, so very interesting, advanced concept, and this is really the pinnacle of our preparation where everything comes together. Some of these topics we had seen previously, right? Voltage drop, voltage regulation, power factor correction, right? And then from that point onwards, these are all advanced topics, maybe minus transformer connections, but our take on transformer connections was really sequence component. Okay. And then we have protection. 4B, nothing included in the handbook, guys. Nothing included in the handbook, right? And we went deep in it. We went deep in the overcurrent protection, which basically includes your differential and as well as distance, right? Then you have protective relaying, you have protective devices, coordination, right? So the strategy that we've used is that for every single line item that they've mentioned in the specification, we know the basics and we know a little bit advanced discussion around it, right? And we did that for these protection schemes. We did that for coordination and so on. And then it's not 100% accurate to say that you don't have any reference for protection on the exam, because NEC is there and NEC does talk about protection, right? Both directly in different articles, for example, motors, transformers, capacitors, and so on, generators, right? And also the catch-all article 240, which is primarily for overcurrent protection, right? But overload is also discussed throughout NEC for different applications. So it's not 100% accurate to say that you're left high and dry, right? For protection. There is reference material in the form of NEC, but then obviously at a theoretical level, NEC doesn't explain you that, by the way, when you're doing differential, anything that happens within the zone of protection is what activates differential protection. Anything that's happening outside the zone of protection. So NEC obviously doesn't discuss any of that. And then when you have a 3-phase system, then what happens, right? You have to count for square root 3 and this and that, and then distance protection, all of that stuff, right? But you're not completely alone when it comes to protection, right? Because NEC, at the end of the day, it is safety oriented, and FPA is meant for safety. And safety in the context of power systems is really driven by protection. Okay, so how about we rate these? So let's say overcurrent protection, let's include differential and distance in this as well. So how is this? Medium to hard. Okay. Protective devices, guys. Sorry, protective relaying, which essentially is the same thing here, right? Has more to do with communication. So I covered this in the on-demand a little bit more detail. Okay, protective devices, fuses, circuit breakers, reclosers, switch gears, substations. I would say medium. I don't think it's easy. And finally, we have coordination, right? So we look at it from the lens of coordinating for the feeder. Then you have coordination requirements for motors, for transformers, for generators, right? So yeah, let's call it medium to hard. I would say medium to hard. Okay, so that brings us to the end of our entire specification review. So if we were to do a quick run through of what we discussed, section 1A, measurement instrumentation, overall easy. Section 1B, obviously, we start getting into some more details, especially with regards to terminology and notation, right? So overall easy with some things that we have to keep track of. Section 1C one of the most important subsections of the entire exam because it contains NEC. Okay, it contains our codes and standard. Okay, so we gave it the due respect, the due attention, both in the on-demand as well as the live training, and the study guide is also loaded with tons of problems. Then moving on to section 2, which is creating the foundation, setting up a launching pad for us to deal with the more advanced concepts. And over here we had symmetrical components per unit and some of the stuff from former FE electrical content as well. So we need to especially pay attention to the stuff that is highlighted in yellow. Moving on, we have 2B, battery characteristics, power supplies, relays, which is a few abstract concepts over here, right? And arguably the most difficult topic is also hidden in here in the form of power supplies and converters, power electronics, no matter how you look at it, right? And the issue we've discussed is the effort to reward ratio is not that great. And for everything else, we have, even for power supplies, we spend a lot of time in the on-demand content. Some students tell me, Wasim, it's overwhelming, right? And follow it up with almost a 4-hour long live training session, right? On that topic. It was the single longest session, I believe, that we had. Okay, those of you who attended it would probably remember it, right? So I don't recommend skipping anything, guys. And if you are in the early phase of your preparation, there's no reason for you to skip anything. Now, if you're consolidating, then you can be a little bit strategic and improvise. Okay. And then section 3, as we discussed, is where things become more interesting, more advanced, more sophisticated with equivalent circuits, graphs, phasors, and we basically dig in a lot of detail. And all of this effort is to help you not only deal with the numerical problems, but also with the conceptual problems, because if you have that solid theoretical foundation, you can deal with it very easily. Okay. And then 3B, also transformer is the king over here, right? And some advanced concepts related to transformers, which we tackled systematically, broke them into pieces. Power system analysis, at the pinnacle of our entire exam preparation, loaded with topics, a range of topics. You can see easy to medium, easy topics, medium topics, hard topics, medium to hard topics. So a really, really nice diverse set of topics over here, and I call it the pinnacle of the preparation. Okay, and then 4B is protection. It's not included in the handbook explicitly, but as I said, NEC contains some details, and we did end up casting a wide net.